Hey guys, welcome back. In today's video, well, obviously you know what we'll be talking about. This has been a very long time coming and we're really excited to share with you our findings. So strap in because this is going to be a long video. So just a disclaimer that this video has not been sponsored by Asiga. All of these opinions are our own and they were not influenced by any outside sources. We were sent this printer from Asiga on loan for a 3-month period, after which we had the option of purchasing it or sending it back. We'll talk a little bit more about that later. Before we get into the review, I just want to thank Asiga though for the trust. These machines are not cheap and we are a relatively small channel. So again, thank you so much for giving us this opportunity. I think the best way to approach this video is to go through the step-by-step process of actually the printing process. So we'll start with slicing and we'll go on from there. So there are definitely some aspects about this printer and the whole ecosystem in general that are very different when you compare to virtually any other machine that we've dealt with or on the market as a whole. Asiga has their own slicing software called Composer. And it's entirely their own as far as I can tell. It's not based off of another system, something similar to that of like Prusa Slicer and Super Slicer being forks of the same software. Composer is only designed to work with Asiga machines. So unless you actually have one of their printers at some point, it won't be of much benefit for me to get into the gritty details. We'll put timestamps down below this video so that you can skip ahead to whatever you want to hear about most. So here are some of the things that I did and did not like about the Composer software. Asiga has developed Composer to run on Windows, Mac, and Linux. However, I am a Mac user and I struggled a lot with a number of issues that were both hardware and software related. Seemingly small things like the Magic Mouse that gets shipped with pretty much every iMac does not have very good support. I wasn't able to right click, for example, and there was really no way to configure that, so I did struggle to kind of move things around, but there are other ways of getting it done, which is how I had to do it. Sometimes pop-up windows would disappear into the background and I'd have to kind of minimize out of the window and retrieve them. I also had some of my imported resin profiles disappear on me without having updated the software. They would just kind of disappear and I'd have to re-import them. And my biggest gripe was the camera. It doesn't have a fixed point of rotation, so if you kind of scroll around, it just throws the whole build plate out of alignment. Now there are quick snap views that you can click and it will bring you back to that view, but it just felt a little bit clumsy. Now I did address all of these issues directly with Asiga over some Zoom calls, and they told us that Mac users are actually a very small percentage of their overall client base, and admitted that the Mac version really doesn't see nearly as much love as their Windows version. It makes total sense from a business standpoint. I can fully get on board with that. It's kind of like how Linux gamers on Steam make up about 2%-ish of the overall user base, but generate something like 20% of the compatibility issues. So I totally get where they're coming from. You allocate your resources where it matters the most. However, this is not gaming. It's an industrial ecosystem that if any customer was to buy into, you would expect to have a smooth workflow on any operating system. So for that regard, I do give them a big ding. On a more positive note though, all of my issues I addressed with Asiga directly, and they actually sent me a couple of builds of Composer that were designed seemingly for me to test and make sure that some of those issues were resolved. So when it comes to the customer support, Asiga is definitely top-notch. They are more than willing to get you back on track and help you in every possible way. But moving on to some of the features that I really did like about Composer were the industry-specific features, such as the ability to add sprues directly onto the model. A sprue is basically the little runner where the metal would flow during casting, in conjunction with or instead of adding supports. Another feature that I really loved was having project tabs. Just like how you would have on a web browser, you can have multiple windows open for different things. On Composer, you can have multiple builds open in different resins, and you can just improve your workflow. I really hope that every slicer at some point implements something like this. It really helped my workflow, being able to get a project going, and if I had an afterthought on another one, I can just open it up, and it just helps me build the queue, because this machine is designed to be running as often and as quickly as possible for industrial applications. I also really like that you can import resin profiles. Much like Chidubox, you can import a .ini file into Composer, which instantly gives you a presumably working printer profile without any other testing required. Asiga actually has an extensive library of resin profiles already made and available for free if you bought this machine. I believe they're up to 400 materials now, and they've all been verified by Asiga to work. And when it came to those resin profiles using a number of the resins that we've got on the table here, this is Resin Works 3D EasyCast 200. We also ran 400. We've got their Asiga resins and Mac 4D stuff. All of them worked flawlessly. The last thing I'll mention that I really liked about Composer was the native support for part stacking. With part stacking, you're able to create a virtual secondary build plate on top or above of the physical one using these support pillars, or you can use multiple supports and actually build like towers of parts that you would just break apart at the end. With this particular model, I was able to fit 2 tiers, but I did have a little bit of extra room. So depending on your use case, you may be able to fit 3 layers. I find this feature to be especially important because, well, the build volume isn't exactly very large on the X and the Y. So it really is important that you can use the entire Z-axis to its fullest potential. With part stacking, a bed like this can hold normally on a single layer 12 rings. The second layer, I was able to fit another 12 rings. And if I were to cast this build, for example, this is actually printed in the Asiga Supercast X, so this is fully castable. If I were to cast all of these in, let's say, 14 karat yellow gold at a retail value of, let's say, 2,500 bucks each, this one build plate could represent about 60,000 Canadian pesos or more, depending on how much you're going to charge for. Jewellery obviously goes up much more higher than that. So I think this is very interesting and something worth exploring. If you guys are interested in seeing more part stacking type videos, let us know down in the comments below. So when you're dealing with sales volumes at this scale, you really need a machine that you can rely on. And I think that's a great segue into talking about the quality of this machine. The Asiga Max X35 is built like an actual tank, like kind of shaped like a tank too. It is heavy, it is all metal, everything about it screams premium. Where virtually every other machine on the market takes a fair few assumptions, especially that about positional accuracy, where the build plate is relative to the printing process. This one takes no chances whatsoever. It knows exactly where that build plate is at all times, giving it an extreme level of precision when it comes to layer height, resulting in a very smooth surface, completely free of visible layer lines in virtually every respect. This is related in no small part to the type of motor and the hardware in general that they used in this machine. For example, most machines on the market today use stepper motors because they're smaller, they're cheaper, and they still work really, really well. However, on the Asiga, they use a servo, which is not restricted to the number of steps that a stepper motor has. Typically, a stepper motor is accurate to 0.05 millimeter or 50 micron in terms of layer height, whereas the servo motor is accurate to 0.02 millimeter. Servos also run faster while maintaining a higher torque value. This type of motor, working in conjunction with Asiga's proprietary smart positioning system, which is located here under the resin vat. This consists of 4 sensors placed under the resin vat, which measure positive and negative forces. In other words, as the build plate is lifting out of the resin, it understands exactly how the model is peeling off of the FEP. And it actually gives you a visual. You can see as it prints down here on the screen and on the web monitoring system, a little blue dot, which actually changes and can tell you if it's peeling a little bit more to the right or to the left. And it actually takes affirmative reaction based off of that smart position. On the flip side of how it understands when it's peeling up, it can actually detect if the model falls off. If you lose bed adhesion, for example, it can take affirmative action to try to fix that, or pause the print so that you don't have a further failure and waste of resin. Something that I was made aware of that I didn't fully understand before we started talking with Asiga was as this build plate approaches the bottom of the vat, there's actually a very large amount of fluid displacement forces that are happening. The best example I could use is taking two pieces of glass with a fluid in between and pressing them together, which is essentially what's happening here. When that happens, there's quite a lot of force being pushed outwards. And when that happens, your prints become inconsistent. The only way that this can be adjusted and accounted for on, let's say, Chitubox, would be a light off delay, basically saying the resin needs 10 seconds to rest. This machine knows exactly when those forces are dissipated. The smart positioning system won't actually allow the DLP projector to activate and expose that layer until all of these forces are equalized, and it does so intelligently so that if, for example, you are printing a pyramid shape upside down, the bottom layers are going to take a lot longer because that fluid force requires a lot more time to dissipate. But as it builds up the pyramid and it gets narrower and narrower, it can take that into account and your print will come out a lot faster. Another thing that this smart positioning does is it actually logs all of those forces in a memory bank, so that if I were to hit the repeat build button, the next time it does this build, it actually remembers where it could start to peel faster or slower, where it had some issues, and it will actually take that into account when it's printing again and make that print go faster or slower to make it better. I think that's absolutely mind-blowing because, as I mentioned before, virtually every printer on the market makes a lot of assumptions. So let's move away from this area and let's talk about what's actually inside. Asiga uses DLP technology in all of their machines. DLP stands for Digital Light Processing, which means that unlike MSLA, which uses an LCD screen to mask off areas of UV light and create the layer, DLP uses a projector, not unlike what you might see at a home theater. And it shines that light directly onto the bottom of the tank, exactly the same as MSLA. This means that there are no screens to replace after, let's say, 2,000 hours, 500 hours of use. And the UV light is way more intense. So the exposure times with DLP are typically very, very short. Depending on the resin you're using, that exposure time may be less than 1 second, literally just a flash. Because the projector doesn't rely on pixel resolution in the same way that masked MSLA does, print quality can be much more accurate and smooth. DLP projectors also have a minimum lifespan of about 20,000 hours as compared to that previously mentioned 500 to 2,000 screen life expectancy. So in the long and the midterm, this is definitely a cheaper machine in terms of maintenance costs. The one downside with DLP in general is that because the light is being emitted from a projector from a single source in a V, the further away that V has to spread, the less details you get on the outer edge of the print. That is an adjustable feature though, and I believe that's why this machine has such a large forehead. Basically, the projector needs some space because it can't just be like sandwiched straight up against the glass. It has to have a gap. That gap is variable, and it actually means that this machine can be adjusted to have higher or lower resolution. Now we have the Max X35, which actually means that the XY resolution that this machine can print at is 35 microns. However, they also have the X27, which is 27 micron XY resolution, but at the expense of a smaller build plate. Essentially, I believe they've changed the height of that DLP projector so that it has a narrower beam and thus a much higher resolution. So talking about the build plate, yes, this is definitely an area where the Asiga struggles in comparison to, let's say, our machines at home, the Prusa SL1S and a Mars 3. The build volume on this machine is actually the maximum that you would get if you were to buy the Asiga Max X43, I believe. This one is actually slightly smaller, as you can see. But don't write off DLP as useless for large format printing. Asiga has already come up with their own large format DLP machine called the Pro 4K. So it's not like this whole issue can't be fixed. It just requires a little bit more engineering. Overall, despite the small build plate size, I didn't find it to be all that bad. I was able to fit some of my larger ear weights on it, albeit one at a time. But I was still able to fit them, and they still printed much faster than the MSLA machines. One of the last things about the Projector we need to talk about before we move on to something else, much like that smart positioning system with the resin, the Projector has its own sensor called a radiometer. And a radiometer measures the UV light output power. The Projector uses UV LEDs, which generally do have a very long life, but the power output can vary and dim with time. This can lead to prints failing over time as the resin is exposed to less and less powerful levels of UV rays. Asiga takes this into account and designs printer profiles with roughly 60% UV power output levels, so that it's essentially future-proofing the machine against that dimming later on down the line. They do make these machines in multiple variants. This is the 385 nanometer variant. They also make a 405 nanometer as well. Before we actually got into the testing, I thought that might be a little bit of an issue, being that they are different wavelengths of light. However, we tested resins that specifically said 405 nanometer with no problem whatsoever, so I really don't think this is too big an issue, but still worth mentioning. 385 nanometer excels at overall print sharpness, as well as somehow transparent resins. As you can see on this guy, this is actually a biocompatible resin. It doesn't suffer nearly as much from yellowing that you typically see with transparents. So moving on away from the machine, let's start to talk about some of those resins. As with many of the other higher end 3D printer brands, Asiga does develop their own resin. However, they are not limiting you to what you can actually put into this machine. You could put the cheapest of the cheap Amazon resin in it, or the most expensive stuff possible. And assuming you have a resin profile for it, they're okay with it. You can print on this machine, no problem. We had the opportunity to review 2 Asiga resins so far, that being their Supercast X and the Supercast S casting resins. You can check out those videos at the links below. One of the most useful features that we found, especially with the casting resins, that you don't see on virtually any other machine, again, on the market, is this little guy up here. This is the environmental controller. This fan down here sucks in the air in the printing chamber, and it heats it or cools it and spits it back out, so that the ambient air inside this space is maintained at whatever temperature you want it to be. Most resins like to be printed at around 25 degrees Celsius. However, there are higher wax variations that prefer up to 35 degrees Celsius. Currently, what we do on the other machines is we will preheat that resin in, say, hot water or in the CW1 on the resin preheat setting, pour it into the printer, and it slowly cools, which is definitely an issue, especially if you're printing something large. Effectively, your print quality can get lower and lower the higher it goes. On an Asiga, that is not a problem at all, because it will maintain that temperature down to like 1 degree, very, very accurately. One of the things that Asiga does to kind of close their ecosystem, however, has to do with the Resin Vats. This vat is a 1 liter low force tray. Now, when this is done printing 1 liter of resin, I'm supposed to throw it in the garbage. It cannot be, you can't take the FEP off and replace it. But I think I understand exactly why they did that. Asiga manufactures their own FEP material. I'm actually not sure if I can even call it FEP, because it could be a proprietary thing like PFA, STEM, PDMS. I don't know what it is, but the FEP-like material on the bottom of the vat is something that they manufacture themselves. Each vat is actually tracked as it's printed with an RFID tag on the back. So this is a completely passive background type system that's working. You simply place this into the machine, like so, and I guess there's a reader in the back that just simply understands how much this tray has been printed with. After that vat has been used up, the machine will no longer allow printing on it, which definitely sucks, especially if you've only got 1 tray and say your new trays are in the mail or something like that. The lowest vat that Asiga makes is the 1 liter, but they also make 2, 5, and 10 liter as well. So if you get the 10, you're set for a very, very long time. For this review, they actually sent us a whole case of 5. of the new low force trays that they developed. Now, how exactly they achieved this, I'm not 100% sure, but I can tell you that there's actually 2 layers of FEP on this that are incredibly thin. Something to bear in mind is that, 1 liter doesn't sound like a whole lot, but in terms of resin, a full bottle is actually less than 1 kilogram, so it equals out pretty well. You'd be able to print this entire bottle in this tray before you have to throw it out. We haven't actually gone through a single tray yet. We still have all 5 of them in use for various types of resin. The target market that they are actively working for typically is dental, audiology, and jewelry. My understanding of the dental practice so far is when you have a 3D printer, you kind of just want to hit go. The last thing that they need to be doing is making sure that the FEP is perfectly tensioned and changing it out at all, keeping track of how often it's used, things like that. That's not on their radar. It's not something that they want to deal with. So they're basically catering to their market, and I don't see any problem with that. And something that I think Asiga realizes and wants to stress by making us buy new tanks is that the FEP is an incredibly important part of the 3D printing process. If the tension is wrong, or actually you can see on mine, I've got these little blemishes where a support poked or something like that, that ruins your print quality. And it's not something that they can really take the chance on. They would rather you go buy a new tank that's been tensioned and done perfectly rather than have their target market mess it up. So one of the last things that we need to address is the ever-pervasive issue of cost. Why would you want to spend $10,000 on a 3D printer when there are so many other cheaper options? Controversially, possibly, but simply put, if you're asking that question, then this machine isn't for you. Asiga machines are an industrial tool, purpose-built for specific applications at a level of precision that even with jewelry is frankly overkill. If a jeweler is off by, let's say, 1/4 of a millimeter, it's not the end of the world. This is designed for medical use, where if you have any variation in the model that you have submitted to the machine to print, that's a problem. This type of printer is not for printing miniatures or anything like that, period. The plethora of sensors and technologies in this machine basically provide absolute certainty that your print is going to be perfect in industries where perfection is the only option. And frankly, to achieve that, quality costs. This is the type of machine where for the industry and the people working in it, time is money. So all of that said, we haven't even talked about the unlimited lifetime support that comes with purchasing this machine from Asiga. If you're having trouble casting with their resin, they will hook you up with someone who knows exactly how to cast with it. Are you having trouble with Composer? Someone will jump onto Zoom with you and basically walk you through exactly how to make it work. So in so buying this machine, you're entering into a community and you're never alone. If you have a problem with, say, a lower ticket type of printer, you might have very limited resources, say like a Facebook group, if that. And sometimes that information isn't even correct. So how long has this video been? Jeez. Yeah, it's time to wrap things up. So what are my personal thoughts after using the Asiga Max X35 printer for the last 3 months? Simply put, I am blown away. During this entire time, I think I had 1 print failure, and it was actually more resin related. The resin was so thick, it didn't want to go into the model. It's really bizarre. I'm normally very confident in my machines. I'm more than willing to just let them print overnight. I know that they're going to be fine. This took it to another level of confidence where there wasn't a question or doubt in my mind that when I came back in the morning or at the end of the print, whenever, the print was going to be perfect and just hanging there for me. I would dearly love to own this machine or virtually any Asiga machine, frankly. Another little issue that we have personally, unrelated to the quality of this machine or anything like that, is that our channel is, we're actively trying to review other printers, and we definitely have a space issue. My studio is like less than 500 square feet, and at home it's even smaller where the printers tend to live. We just don't have a whole lot of room to have, an Asiga and a Jupiter, and the next thing down the line. We just can't commit, unfortunately. We would really love to down the line, and we know now that Asiga is definitely a great place to go when we need a high-end 3D printer. So thank you all for watching. I know this has been a really long video. If you like this content, please like and subscribe so you don't miss out on all the other cool things that we have lined up for 2022. If you have any questions about this machine or 3D printing in general, casting, jewelry manufacture, feel free to leave a comment. Please consider joining our membership program where you have access to me on a more one-on-one basis through Discord. Thank you very much for watching. I will see you guys in the next one.